All right, well, good morning, good afternoon, good evening. We're recording 6.5b here, so we've got section 6.5. We're talking about polynomials and how to factor them, and we want to really just be fluent in factoring, because factoring is going to be a big part of Math 141 next semester. So we want to just be really fluent in how to factor things, and also how to recognize special patterns in those factoring. Sometimes, right here, for example, in section 6.5a, we talked about difference of squares. So that was something, special pattern that was easily factorable. That difference of squares is factorable as well through the AC method. But if you recognize, and the AC method and the trial and error method, but if you recognize that this pattern specifically is difference of squares, then hey, you're miles ahead. You don't have to go through the AC method. Same thing holds true for perfect square trinomials, this one here that we're going to work on today. Today in section 6.5b is perfect square trinomials. If we recognize the pattern, we won't have to go through the AC method, which is kind of long, or the trial and error method, which is kind of long. Both of them also are possible, or it is possible, I guess, by using those, it is possible to make mistakes. So, that said, we're going to go through a couple of patterns that we can maybe recognize and not have to worry about factoring completely. One was difference of squares, that was 6.5a. Today is 6.5b, or this one is 6.5b, perfect square trinomials. So here's our difference of squares and perfect square trinomials smartboard presentation. We talked about difference of squares right there, a squared minus b squared right there. And if we recognize that, we know that it's a minus b, a plus b is our factorization. All right, another pattern that we can recognize and probably should recognize is this one here, the perfect square trinomial. So let's take a look at what the perfect square trinomial is. A perfect square trinomial, right there, results from the multiplication of some base or a binomial, a plus b. A could be numbers and or variables. B could be numbers and or variables. But when you square the entire thing, remember that squared goes to the entire base, and what it looks like is over here, a plus b squared is a plus b times a plus b, because that squared is working on our base. The base is a plus b, we're squaring it, so what does that mean? If we FOIL it out, it's a squared, the first term. Outside terms are plus ab, inside terms are plus ab. Last term is plus b squared. Now this one here, ab, could be ba, but it's also ab because of the commutative property of multiplication. Now when we get this one here, that's where the pattern kind of comes in. We've got a squared then plus, when we combine these terms, plus 2ab plus b squared. So this middle term is 2 times a times b. In other words, 2 times the square root of this one, a, times b, which is the square root of this last one. And we'll notice that when we square this, a plus b times a plus b, even if this is a negative number, if it's negative 7, for example, negative 7 times negative 7 would give us a positive number over here. So that first term has to be positive. Likewise, for this b times b gives us b squared, and it has to be positive, because even if that were negative, you'd have a negative times a negative and you'd still have a positive. So that this term has to be positive, this term has to be positive, and this term in the middle has to be twice the square root of that times the square root of that. So that said, this is what a perfect square trinomial looks like, because we started with a plus b quantity squared, and this is what we got. So if we've got a perfect square trinomial, these things are true. Those are true. In order to figure out if we've got a perfect square trinomial, we have to look at a couple different things. We have to kind of make our life easy, just like working with other polynomials. Number one is write the trinomial in descending order. And that means that our squared term comes first, our to the first power comes next, and our a to the 0th, in this example, a to the 0th power comes last, because this is a to the b squared times a to the 0th power. So we write this in write the trinomials in descending order. Step number two is the first term a perfect square? Is this term a perfect square? Could be numbers, could be variables. Remember, if it's a variable, this power has to be divisible by 2, so it could be a squared, a to the 4th, a to the 6th, all those are perfect squares. The numbers also have to be perfect squares. Right now there's just a 1 right here, and that is a perfect square, but it could be 4, could be 9, could be 16, could be 25, etc., etc. And that's where memorizing those perfect squares comes in very handy, and it's probably more than a nice to know, it's probably a need to know. Those perfect squares up to at least 15 squared is 225. So step number 2 is the first term a perfect square, both numbers and variables? This one is. Is the last term a perfect square, both numbers and variables? This one is. B squared is a perfect square. Is the sign on both the first and last terms positive? Is that sign positive? It is. Is that sign positive? It is. And again, this is not written down as a sign, so we have to assume it's a positive sign. Step number 5 is the one that kind of takes a little bit of time, but it's worth it to find that perfect square. We have to calculate the square root of the first term. So if we do that, up here I'm going to use this as an example, and I'm going to say, let's calculate the square root of a squared. What's the square root of a squared? That's a. Part of number 5 is calculate the square root of the last term as well. Square root of the last term is square root of b squared is b. And now we have to multiply these two together. Multiply a, the square root of this term, times b, the square root of this term, times 2. And we have to say that it would be 2 times a times b is our 2 times this first term times the last term. And this, if this, then step number 6, I guess, is if this matches our middle term, then we do have a perfect square. And sure enough, 2ab matches 2ab, and sure enough, we've got a perfect square. So let's use these, and in fact, I'm going to go here, and I'm going to say right here, if you're setting up a cheat sheet or a study guide, all these should be something that you should write down and say, now I'm going to try and memorize these, or I will memorize these, and so I can recognize a perfect square trinomial. All right, so that said, write those down. I recommend either writing it down or printing out this page and saying, I'm going to refer to this just to make sure that I can find that perfect square trinomial or the pattern. And let's do a couple of examples. Now I'll do A. Let's start with A. And here we've got x squared plus 14x plus 49. And the instructions are factor these trinomials. And oh, by the way, they're perfect squares. So we're giving you the fact that they are perfect squares, but let's go through the factorization and the confirmation checklist and see if these are perfect square trinomials and see that they do fit the pattern. All right, so step number 1 is write things in descending order. I've got x squared plus 14x to the first power plus 49x to the 0th power. Okay, so we've written in descending order. All right, is the first term a perfect square? X squared is a perfect square because 2 is divisible by 2. Is the last term a perfect square? 49 is a perfect square because it's 7 times 7. Is the sign on this term and that term positive? It's unwritten right here. There's no sign here, so we have to assume it's a positive. And this is written down as a positive, so there we've got a positive and a positive. Now the last thing is to confirm that this fits the pattern. So we have to do our kind of little calculation here. And I say, what's the square root of the first term? Square root of x squared is x, and that should be our a term. What's the square root of the last term? Square root of 49 equals 7, and that should be our b term. And now we have to find out what 2 times a times b is. 2 times a times b is 2 times x times 7 is 14x, and sure enough that matches there, so that fits. That now allows us to say that fits the criteria of the perfect square. So now we have to say, what's our factorization? Factorization should be a and b here, perfect square, and we have to match this sign here. This sign comes down to say that this would be a plus b squared. So we got to fill in just the blanks here. A is x, b is 7, here's a 7, and we add a plus sign, and we should probably double check by foiling. Sorry, that should be squared. We should now double check by by foiling out. X plus 7 quantity squared is x plus 7 times x plus 7. First term is x squared. Last term is, outside term is plus 7x. Inside term plus 7x. Last term plus 49. And combine the like terms to get x squared plus 14x plus 49. And 49. Is that the same as right there? It sure is. So that checks out. And that then is our factorization right there. Perfect square. All right, let's go through another example. Let's go through this one here, and I'll say b. Let's work on this one and say, is it a perfect square? We could factor this. We could say if we're told to factor these trinomials and this perfect square weren't written, we'd have to say, well, I can go through the AC method, I can go through trial and error, but you know what? Let's maybe see if it fits the perfect square pattern, because it sure looks like it, because this is a perfect square, that's a perfect square, there's a positive and a positive. But let's go through the criteria. Number one, we've got to say write it in descending order, because that makes our life easy. For every trinomial, we should always probably try to do that. Here's y squared, y to the first, y to the 0. Okay, there's our descending order. All right. Second criteria, is this a perfect square? That first term a perfect square, 25 is a perfect square, y squared is a perfect square because 2 is divisible by 2. Is this last term a perfect square? 4 is a perfect square, it's 2 times 2. Is this first term positive? Yep. Is this last term positive? Yep. All right, so now we have to calculate and say, now we have to match that middle term and hope that that middle term matches our 2AB pattern. In order to find 2AB, we have to find out what A is. A is the square root of 25y squared, and that's equal to 5y. B is square root of 4, and that's 2. So our 2AB is 2 times 5y, because that's our A term. Our B term is 2. So multiply all this together. 2 times 5 is 10, times 2 is 20y, and that matches our 20y. So sure enough, it is a perfect square, and we now have to put in our perfect square factorization as A and B, and this sign here has to match the sign on the middle term. So there's an A minus B quantity squared is, fill in the blanks now, 5y minus 2 quantity squared. And we should probably FOIL it just to double check. 5y minus 2 times 5y minus 2. If we go first outside, inside last, we go 25y squared minus 10y plus 4. Combine the like terms to get 25y squared minus 20y plus 4. And does that match what we've got up there? 25y squared minus 20y plus 4, and sure enough, that does match. So there is a correct factorization. We've double checked, and we can move on. All right, well, that said, let's go through. I'm going to ask you to pause the video pretty soon, but I'm going to give you some direction here. Do C and D and factor those according to the perfect square trinomial criteria, and then use, find your A, find your B. Does it match the middle term? Positive, negative, descending order, all those criteria. Use those criteria on C and D, and then see if you come up with the same answer that I get in the video. All right, so pause the video and work on these, and we'll come back. All right, so now we've got a couple of examples here. We've got the red example, we've got the blue example, we've got A and B. So now C comes in. We're going to do this as green. So we're going to say, does this fit the criteria? Number one, let's make our life easy. Are these in descending order? Are the terms in descending order? X squared, yep. X to the first, x to the 0th. Okay, they're in descending order. So now, is this first term a perfect square? X squared is a perfect square. Is 9 a perfect square? It is a perfect square. Is the sign here positive? Yep. Is the sign here positive? Yep. All right, so now comes the kind of the hard part. We've got to find whether this 6x matches our pattern. So A equals square root of x, square root of x squared equals x. B equals square root of 9 equals 3. 2AB equals 2 times x times 3 equals 6x. Does that 6x match the 6x? It sure does. So we've got a perfect square trinomial. Our perfect square trinomial factorization should be A and B, and the sign here in between A and B matches the sign on the second term. So there's our A minus B quantity squared equals, now we just fill in the blanks, x minus 3 quantity squared. And now to double check, we should FOIL. X minus 3 times x minus 3. First outside, inside last gives us x squared minus 3x minus 3x plus 9 equals, combine like terms, x squared minus 6x plus 9. Is that the same thing as what we started with? X squared minus 6x plus 9. It sure is. That checks out. Our FOIL checks out. So our answer is x minus 3 quantity squared, and there's our factorization. All right, so now what I'm going to ask you to do for this one is do this one as homework. So factor this one out. This one is a little bit more challenging because it's got 81 and it's got 16. It's got bigger numbers, but we should be able to follow the pattern of what we had before. In fact, this pattern back here, if you didn't write it down, there it is. If that pattern confirms, especially that middle term is following the pattern, then we've got a perfect square trinomial, and you can factor it as a perfect square instead of using the AC method. So that's going to be the homework. So for this section 6.5b, make sure you've taken some good notes. Write down D as your homework, include that with your notes, and put it in my Dropbox, and bring your questions to class. See you soon.